So, we human beings have a tendency to think in terms of what is familiar to us. For example, when we think of colonizing space, we think of finding planets which are like Earth. There's a lot of talk about what is the habitable zone and how many planets are there in the habitable zone. So essentially, you're looking for something that is familiar. And what is familiar to us is Earth. And when we think of, okay, maybe we can find another Earth like planet, and so that's where a lot of the excitement or a lot of the research is directed towards. However, if you look at the numbers and if you look at what we know about the laws of physics, and given that I believe in the future humanity will want to increase its numbers because the idea of comprehensive utilitarianism says that it is a good thing if we are able to provide a good life for more future humans. So, given all those facts, what follows is that we are actually, or humanity in the future is actually going to live in space habitations. They are not going to go searching for these, planets in the habitable zone, because if there are such planets, they are probably very small in number. Whereas every solar system has a fantastic amount of mass, which can build a fantastic amount of space habitations in which a fantastic amount of human beings can live. So that is the future. So now I'm going to tell you how Earth fits in that future. And you're going to your first reaction is probably going to be no way. That's not going to happen. That's just that's impossible. And I like that reaction. If I was to only tell you things which you already are familiar with, I'd be disappointed. I want that reaction from you. Oh, he made us think something new. Okay, so that's what I'm looking for. And just think, okay, now this is a look into the future, like what's going to happen a few million years from now. And have an open mind. Just go back 1,000 years. 1,000 years ago, if somebody you knew told you someday humans will walk on the moon, people would say he's crazy. As technology advances, new things become possible which were not possible in the past. And there is technology and there is knowledge of science. Okay? So the technology is not yet here, but the knowledge of science can point us in a certain direction. And what is that direction? Well, I've already, in a previous video, I've said why we shall not colonize Mars. Rather, we are going to break it up, send it to space, and create space habitations for more than 20,000 trillion people. The same thing is going to happen with Earth. So what is going to happen? Like, think about, like, you're a couple of million years in the future. Now, this is a glimpse for you about where humanity will be a few million years from now. Okay? And it follows from numbers. So the first number that you have is that Earth's mass is about 6 into 10 to the power 24 kilograms. If I have it right, a trillion is 10 to the power 12. And so 10 to the power 24 is a trillion kilograms. Okay. So that's the first number. The second number is how many space habitations can you build with that amount of mass? And according to the design which I provided in earlier videos, a space habitation for 50,000 humans will require 1.42 into 10 to the power 12 kilograms. Okay, so then the number of space habitations you can build will be about 5.97 into 10 to the power 24 divided by 1.42 into 10 to the power 12, and that should be about 5 into 10 to the power 12, or 4 into 10 to the power 12 space habitations, and each space habitation can provide food, clothing, and shelter, and fun, all kinds of luxury for 50,000 humans. So the amount of humans who can have this food, clothing, shelter, and luxuries, if you take the mass of Earth and you convert it into space habitations, using solar energy, because solar energy is it's an infinite amount of it, is 210,000 trillion humans. So you know where this is going. If you remain on Earth, there is enough for maybe 8 billion people. If you convert Earth into space habitations, there is enough for 210,000 trillion people. Now, if you look at it from an economics point of view, you can kind of think of it this way. So, according to one estimate, the value of all land in the OECD countries is about $130 trillion. Okay. Now, take that as a lower estimate. So just say that the value of all land on Earth is $130 trillion. So we have a population of about 7.9 billion, and that works out to about $16,500 per person. So on Earth, the average value of land which is owned by people on Earth is about $16,500. So compared to Earth's current population, and if Earth was broken up and instead there were 210,000 trillion people, that would be 26.6 million times more people who could live in those space habitations. Now assume that the value of land in space will be approximately the same as value of land on Earth. Now space habitations, the value of land will probably be a bit more because space habitations have some advantages. There are no issues of pollution because the modules which build the space habitations are periodically just disaggregated into their constituents and fabricated again. So uh, but let's say that the value of land in space is approximately the same as value of land on Earth. So total value of land will be in space. If you broke Earth and made it into space habitations, the value of land in those habitations would be 3.46 billion trillion. Okay? And if you say, okay, you were to take that money and distribute it to the inhabitants of Earth, that would turn out to be $430 billion. So each person on Earth could be given land which would have a value of $430 billion if they agreed to break Earth into parts and send it off to space for the construction of space habitations.